Hello, hello, hello. Good morning, chat. What is up? Happy Friday. How's it going, guys? Right, Joy-Con, Jordy, Alchemist. How's it going, guys? Hello, hello. Happy Friday. Today is Friday, right? Flake me, daddy. Oh, don't worry. We're probably not going to be dealing with actual flakes today. We're going to be looking at just derivations, but flakes do make derivations, so kind of. What's up, Agile? How's it going, buddy? Yo, Shixie, hello, hello. Ionic Kevin, what's up, dude? Hello, hello. Good morning. Good morning, everybody. I hope you guys have had a fantastic week. I hope it's been great. Mine's been interesting. I don't know. I'm just tired, man. I'm tired. It's been a long week. I don't know how you guys feel, but like, this week felt like a long week for me, man. Emotionally, physically. Just a lot. But I'm ready for the weekend, man. I don't know about you guys, but I'm ready for the weekend. I'm ready to chill out. My dactyl came in today. Hell yeah, Cowface, dude. Congratulations. Somni, what's up, buddy? How's it going? What's up, Nate? How's it going, dude? How are you? Yo, what up, dude? I feel that KubeCon has been exhausting. I know, right? I wish I would have been at KubeCon, though. Honestly, Somni, I'm pissed a little bit that I wasn't at KubeCon. I that should have been the one I was at. I didn't do it. So next year. Yo, how's it hanging? It's good, man. It's good. I got Arch on my new M12 last night, but the touchpad sucks. Yeah, that's one of the big reasons why I don't actually use Mac or Linux on Mac. The best way of putting Mac peripherals and hardware is it's all closed source. I guess the easiest way to put it is if you want to have a super good experience, virtualize, create a VM, and then run everything inside that VM. I heard there's a way to use Nix with OS X. There is. Yeah, there is. Yeah. Nix itself is just a command line tool with package manager. And so on Mac, it works a bit like Homebrew in that regard, which is what I was talking about before. Purple Elf. Oh my gosh. Purple Elf, you are so kind. Thank you so much for the second raid. Thank you. I swear to you, I popped into your stream for about 5 seconds the other day. I was enjoying the community and the vibes, and then I got called into a meeting and I had to go. But I do want you to know I did lurk your stream the other day, and I did enjoy it. So thank you for the awesome content. I appreciate the raid as well. How are you, though? How's everybody from Purple Elf stream? Hello. How are you guys? I just started my stream again, so yeah. So that's what I was feeling. Yeah, sorry. Just me lurking in the corner like usual. Oh, wow. Okay. That works too. Thank you. Or the opposite. That you're too sweet. Thank you for the raid. Thank you. How was your stream? How's everything going with you and your community? I just started. Like I said, I just started streaming, so I literally just started. It was great. Thank you for asking. How are you? I'm good. Yeah, I'm okay. It's been a crazy week, honestly. I was just telling chat, man, the human experience. If I'm gonna be honest. If like before my birthing, if there had been like somebody who just like stood up in front of me and been like, all right, listen, so here's what the human experience actually is. Here you go. Here's what you're going to What do you think? You know what I mean? I probably, that's a lot. It's been a long week, but it's, thankfully I'm excited for it to be the weekend. Yeah, but I'm doing all right outside of that. Helping with triage, find a well-maintained. Oh, we're not talking about what I'm talking about. But the pseudo Nix within OXS thing picked my interest. Yeah, so everybody from Purple Elf stream, thank you guys so much for being. Oh, I forgot my coffee. Listen, chat. If there's one thing you absolutely need to know about me, all right? BG needs his coffee in the morning. If I don't have my coffee, I don't function. So sorry. That's why it's important that we be gentle with each other so we can make human experience the humanity experience. I agree. It's interesting. I grew up, and I'm just going to go into this super quickly. I grew up super white, privileged, closed-minded, separated from the world, and in the South. Whew. So there was a lot of mental hoopery I had to jump through when I moved to California in a completely diverse ecosystem. Yeah, it helped me appreciate how much, like, I guess the easiest way to put it, how much we should probably realize we share this world, rather than just, living in it by next to each other. You know what I mean? Purple Elf, thank you so much again. Let me give you a shout out really quickly. Everybody, be sure to follow Purple Elf. They are absolutely wonderful. They've been very supportive to us recently, and again, awesome streamer as well. So go give them a follow. Thank you again. Thank you so much. Have a great rest of your day. And everybody from Purple Elf Stream, thank you for being here. I really appreciate it. I'm a little tired, so I'm a little out of it. So I apologize if I'm not exactly on my direct game at the moment. But don't worry. Once the coffee gets in me, we'll start pumping. You know what I mean? We'll be. Well, that didn't sound right. We'll be moving forward, chat. That's all I'm trying to say. Yeah, it was a lot of unlearning. But yeah, if you guys are just joining here, hi, I'm BG. I'm one of the co-hosts of the Alta 4 stream. If you're new to our channel, there's a little blurb about us right there. Well, it'll be there in a second once the bot decides to wake up. TLDR, I am a DevOps engineer. I've been doing this for quite some time now. I've been a software engineer in general for about 10 years, and I've been a DevOps engineer for probably about 3 to 4, I think, maybe at this point. I've been doing it longer, but to say what I define as DevOps is not what I was doing when I first started it. I have a lot of interests. I like to work with a lot of different things and like learn a lot of different things. And so one of the things that we are learning is something called Nix. Now, I've been covering this, okay? I've been covering this, so I highly recommend you take a look at our VODs if you are curious entirely of like what Nix is and stuff like that. The reason why I say that is because I've been going through a series, what are called the Nix Pills series. And so if you guys don't know what this is, essentially, it is a series written by the community focused on developer adoption, getting people into Nix, why you should use it, things like that. A quick TLDR on what Nix is. It is a build system. That's the easiest way to put it. It is a build and configuration system that is designed to help you build and configure software. And maybe not configure in the sense of like deployment configuration, but configure to build software. The majority of the benefits, and like Nate, I want to like be clear to you even on this as well, and anybody who's interested in really like jumping on the Nix cord or the Nix bandwagon or whatever you want to call it. It's really focused on the build process. Now, because the build process is intrinsic to a lot of what we do, there's a lot of other really cool things you get out of it. Things we've talked about already, like the Nix shell and the Nix development environments, being able to like not need containers, but still have, every version of every piece of software you could want, as well as a bunch of other things. So I do want to be fair that like if you're not building software a lot, if you're not dealing with building software a lot, or you're not in a scenario where, you're not configuring your development environment often, or things like that. Honestly, Nix might not be a massive impact to you. It might be helpful in the sense that, it'll be like a set and forget, which it really does become. But one thing I have learned about Nix is like to really get the value out of it. You want to be using it as often as you can and like introducing it into as much as, your development flow and stuff like that as possible. Nix is pretty cool for persistent devems. It definitely. Again, it's cool for a lot of things. Don't get me wrong, it really is. But like I guess what I mean to say is like if you're just writing, like I don't even say writing code because it could still help you with that. But anyways, hold on one second. Okay, so as I've said, Nix focuses on building software, right? And to catch you guys up on the pills we've essentially done up until now, it's really just been why you should give Nix a try. That's the first pill. So if you're interested in why even giving it a try, I recommend taking a look at that pill. The second pill is installing it on your system. And Nate, this is where I kind of want to reach out a second to you as well. I know you were interested in installing it on Mac OS. If you do Nix, I don't know if it's the wiki. Maybe, or no, wait, NixOS. Is it here? Yeah. And so if you go to download, it's Nix Darwin. That's what you want. Yeah. Here's what you do. Basically, you run this first, right? This will install Nix itself. And then what you're going to do is after you have this installed, and like, don't forget, you're going to have to like restart your shell and everything because Nix like creates new shells for you and stuff. After you do this part, right, then you do Nix Darwin. And it literally, the great thing about Nix, right, is that it literally leans on Nix build, right, to install Nix Darwin for you. So once you have Nix, you really have everything you need. There's going to be a little bit of gotchas. Like, for example, I would highly recommend reading through this article because it'll tell you of like what you might run into and stuff like that. Yeah. What is my keyboard? I have a Moonlander. Yeah. There you go. That's my keyboard. Cool. Well, yeah. And so that's basically my little introduction to Nix for you. It's a very, very advanced build system that helps you build software very reliably. And so we talked about the environment, and Nix basically is containerless. It doesn't have any kind of virtualization or anything like that. Nix really kind of works a lot like Homebrew in the sense that it's just storing files in a location on your computer, and then it's referencing those files and creating shells for you. It's way more advanced than Homebrew, and it's not exactly the same in Homebrew, like really technically at all. I'm just simply saying that in the sense of they both, store their data in one location, and that's where everything goes. They're similar in that regard. Then we talked about the basics of the language yesterday, as well as functions and imports, right? So we've had a good, I think, introduction of a lot of what Nix is, right? It's a language, right? It's a package manager, right? And it's an operating system. So we're going to work today on actually building our first, what we call derivation. So in the Nix world of things, right? We don't call, like you don't really actually call a package a package. It's not really a package. It's just a configuration description, right? And what Nix does is remember, Nix evaluates everything, right? And so when we pull down that configuration or that description of how that piece of software is built, it is evaluated, right? Like a software or like a language, right? And so those evaluations that turn into essentially builds are what we call derivations, right? And the main idea behind this concept of like derivations really is just that it is a specific derivation of some type of build, right? It is a specific change set, right? That is only this change set, will never be any other change set. And this change set represents this specific, again, derivation of the build, right? And you can have 5,000 derivations of the same piece of software. Why? Because maybe you changed the code 5,000 times and built it 5,000 times, right? That's what we mean by a derivation. It's literally saying, okay, this is what this is in this given state and time. When we build it, this is what we're going to say it is, right? So even if you go into to be clear, even if you go into a whole application with Nix and you change one character, just one character, that is enough to bust it and say, okay, this is a separate derivation, because it knows how to check everything and validate and make sure that it's either the right checksum for the change set or the wrong checksum for the change set. So that's another thing that's very, very important about this concept of derivations is we're not just rebuilding the same package over and over and over and over and over again in the same environment, but what we're doing is we're rebuilding the same package as many derivations that exist on our computer. And so if I do ls-alh nix store, right, you see these .drvs, all of these .drvs are my derivation. So if I do grep, drv, oh, whoops, maybe I didn't do that right. There it is, yeah. So see all of these. So if I was like neovim, look at how many times I've built neovim. And look, you'll see look, this is 080 and this is 080, right? This number here is kind of pointless to us in a Nix world. Like, to be completely honest with you, master 080, like these version numbers don't really mean anything to us in a Nix world. What really matters to us is this right here, this SHA, This SHA is what tells us which derivation of change sets we're going to be using. And so again, 5.2W or RWA NeoVim 080 is actually a different derivation in some regard than GRPHX NeoVim 080, right? And this is where it differs, I would say, a bit from something like, Homebrew, where Homebrew just says, like, I'm just going to, get the final output packages, put them in a directory, bim, bam, boom, call it a day. This actually says, no, I'm going to look at everything required to building this and all of its change sets. I'm going to put everything in one place. And it's just going to be, again, what we call a store, this massive storage location that has all of these derivations inside of it. And we just link to the ones that we need for our shell environments. And that's what makes it so we don't need any kind of like virtualization or, anything like that. Hold on one second, chat. Sorry, I had to reply to somebody in a friend's Discord. Okay, cool. So let's go ahead and jump into our first derivation. Does anyone have any questions about derivations? Right, like the TLDR again is basically anytime you make a change, you get a new derivation. That's going to be its own set of build files and everything else with it, right? Gonna use sorry, let me catch up with chat as well. I'll probably end up with OS X, Nix, Arch, Ubuntu, multi-boot. Good God, man, you're gonna hate your life. I'm sorry. I just like debugging that sounds like a nightmare. Not to say that you couldn't do it. Again, you definitely are an intellectual person. I definitely think you could handle that challenge. I do think you would probably spend. So Nate, here's what I'm gonna say to this, dude. And here's what I'm gonna say, because I've met you in person, right? We got the honest opportunity to hang out with each other. Don't forget your day life and how much time you get in a 24-hour period. As a friend who's been down the OS X, Nix, Arch, Ubuntu, multi-boot, and I say this to everybody. I say this literally to everybody. Anybody who brings up multi-boot. You're probably going to spend a lot of time debugging it. So just be aware of that. Just be aware that it might be challenging. That is why I, as somebody in chat mentioned, I go the VM route. Because if I break a VM, dog, it doesn't matter. I'm not locked out of my whole system. I don't have to figure out my bootloader. You know what I mean? Like I don't have to debug why my operating system's not being detected from a hard drive level. You know what I mean? Like it's not as terrifying, right? And so that's like for anybody out there who wants to like try out these operating systems and do these things. Like look, I'm doing it. I'm literally like, this is one of the few times where I'm like, do as I say and as I do. I am such a massive advocate of deving in VMs, especially if you've got the power for it. If you got the pow pow, man, if you got some of that pow pow in your computer to be able to like actually host like 5 VMs at a time, dude, you got more than enough power to create yourself a VM, a dev VM, and have it like set up exactly the way that you want it to. Does WSL count? No, because WSL really tries to like, so, okay, listen, guys, listen. I understand that there's this massive argument around, and we're going to get into our derivation in a second, but I gotta, like, this is another thing I'm a massive advocate for, which is like people having the right expectations around virtualization. So I'm going to give you those expectations now. About 10 years ago, the overhead of a virtual machine was a lot. It was a lot. And it was not very common to run VMs, especially while you're trying to run heavy workloads on your personal computers, essentially, right? That's why we ran them in the cloud. Fast forward like 10 years now, most processors have virtualization built into them now. Virtualization has become a much more common utility. And it's being used in a lot more applications. And so virtualization's need has become much higher. Because of that, our CPUs have just gotten better with them, okay? I run, if you were curious to ask me like how, like what do I run? Hold on. Okay. I didn't want to like, accidentally show anything. But I run, if I go to Task Manager, I run a i9900K, right? 3.6 gigahertz that goes up to 5. Now, granted, I run at the time when it came out, the best CPU in the market. Nowadays, it's, probably not that great, but it's still a pretty good CPU, right? So if you look here, we've got 4, right? 8, 12, 16, right? So we've got 16 logical processors here, right? The reason why I'm showing you this is because I've got 8 cores and 16 logical processors, right? What did I do? Well, if we go to my VM settings, look at this. I gave it 16 logical processors. Now you might be like, BG, what the? Why are you doing that? You're giving it literally all of the computational power on your machine. I mean, yes and no. It's technically not all of it because these are shared, right? So if I'm not using any of it, then I'm not using 16 processors. It doesn't really matter. However, if I am using all of it, I'm pretty much fine. The only time it becomes an issue is if I'm using all of it in my VM and then I'm trying to use it, somewhere else, say like a video game or something like that, right? My point of showing you that, though, is to help you realize that, like, there is actually nowadays not really much of a overhead. It's more of just like how much you give the VM, right? And how you manage the resources on your computer. When I'm developing, like when I'm working in Nix, do you know the only other thing that's open on my computer right now? It's this. It's Firefox. Like, I don't really keep anything else open because I know where all of my computational power needs to be, right? And then when I want to play video games and stuff like that, what do? I just shut down the VM. You know what I mean? And then I go play video games. Another nice thing about that guarantees that anything that was running in the background is off, right? I don't accidentally have containers running while I'm trying to play video games or something like that. And so that's why even like WSL, in my opinion, kind of falls short because, it's just kind of always running. And you can stop it, but it's just not practical to stop WSL. Trust me, I know how to stop WSL. You just don't really do it. You don't really think to stop that actual thing. New question. Why is it important and good case of unit testing and mock testing for Python? I mean, listen, if you are a organizational company that is trying to build software, manage that software, and basically like, provide it as a service or something to people, it probably makes sense for you to do testing. That's just me saying that in general for any language, any application. Like, testing is not bad. We are just bad at doing it. And we're really bad at making tools that help make testing easier. It's actually unfortunate to say, but it is true that like most of our testing tools are lackluster compared to like the tools we make to build, the actual applications with, which is a bit unfortunate. But nobody like testing just like in comparison to the rest of software engineering's focus, testing is just, it's not something that's what do we have? Jest? Like, think about this, chat. What happened? JavaScript had Jest in the Jest world, and then they were just like, you know what? It works, and we've had Jest forever, right? We've had Mocha and other things like that, but like Facebook wanted to capitalize on the testing market. So what did they, like, on a market they knew they could for a while, right? Because nobody's really interested in fixing testing. Right, and so what did? They make Jest, and then bam, there you go. Now it's like the '1 testing. Facebook did the same thing with components, and until we finally got like Vue and Svelte and all those other ones. But so yeah, testing is good in general. Like, it really is good in general, but be aware that it is challenging. It's not always easy. You know what I mean? You got to do it. Got to do it. End-to-end testing is a little different though than unit testing, so just be aware of that. Which VM software am I running? I use Workstation, VMware Workstation. Yeah. How hard was it for you to get my first dev job? So to be clear, I wasn't actually trying to get my first. Yeah, you're welcome. I wasn't trying to actually get my first dev job. I was pretty broke, and I wanted to be able to make money while I was trying to be a while I was trying to be a writer and director in LA. And long story short, I kind of took a customer support job out of necessity. That was adjacent to, and basically a web hosting company is what I was working at. And they had a software engineering department. I was, bored and falling back crazily in love with engineering and programming because I was doing it for my day job with not engineering, but like, servers and stuff like that for customer support. And so I worked like a solid year. If you were to ask me like how hard was it for me to get my job after I realized on the customer support floor that I wanted to do it. Yeah, it was like a solid year of me regaining all of my past experience and knowledge as a kid, to catching up to like things that are doing today, working with other engineers and like shadowing people. And after about a solid year of just like every night working on code and building things and building multiple things for the company as well, I just started fixing problems on the CS floor and making tools for the customer support agents, right? Like I didn't have to. They weren't like official things, but they were just things I made on this free time, and they kind of realized that, I was somebody who wasn't just a customer support agent. And so after about a year, I got moved out. About a year, I guess, is the best answer, in time frame. But it was a lot of work. Like I had no social life. I was not doing anything. I completely changed my whole life around just to focus on learning. Did you learn web dev first? I did. Yeah. I started in front end. I went to back end. Then I went to full stack. Then I went to, what did I do? Yeah. No, it was software engineer as a general, and then senior software engineer. And that is what I am today, but I work in DevOps now. All right. So let's go ahead and jump into this Nix stuff, because this is stuff that I'm very excited about, sharing with you guys. So as I said before, we're going to be building our first derivation today, right? This is our 6th Nix pill that we're going to be working with. So let me actually go ahead and go to our script, Nix explained. Cool. You know what I probably should have done? I'm going to delete these because I probably should like create directories of like chapter, like, you know what I mean? Like 06, 05. So I know like which references these things are in. Yeah. Okay, welcome to the 6th Nix pill. By the way, I want to say this really quickly for any of you guys who have been here throughout this whole series and like, patient and following along with this, how, this Nix pill series or whatever. Thank you. It's crazy to think we're already on chapter 6, but like, yeah, I'm excited. Honestly, I've really been enjoying it. I would say, if you're curious on a couple of the things that really stood out to me, right? It was probably the basics of the language and functions and imports. These two, right? Like the last two, 5 and 4, were really like interesting to me. I actually really enjoyed those ones probably the most. What are my socials? Well, we have social medias. You can follow us on Twitter. We also got some YouTubes as well. Okay, in the previous 5th pill, we introduced functions and imports. Functions and imports are very simple concepts that allow for building complex abstractions and composition of modules to build a flexible Nix system. These two words here, abstractions and composition, I think are a very common thing within Nix. And it's something that I think is something you're going to want to learn how to get like better at, and something that I'm learning how to get better at with Nix especially, which is like, when do you abstract away something, right? And how do you compose that abstraction, right? These two things together are actually very, very, one of the things I really enjoy about writing Nix, but also, definitely make it challenging for sure. In this post, we finally arrived to writing a derivation. Derivations are the building blocks of a Nix system from a file system viewpoint. The Nix language is used to describe such derivations. right? So, and that's what I said earlier, where a derivation is not really like something that's already been built and sitting somewhere waiting for you to download and install it. A derivation is really the output of a configuration described in the Nix language, right? It is the byproduct of the language configuration, or the configuration in the language that you make. So let's go ahead and work on, or let's go ahead and move forward. So we want to go ahead and enter our Nix environment. I'm on NixOS, so I've already got Nix available to me. Cool. Okay. The derivation function. The derivation built-in function is used to create derivations. I invite you to read the link in the Nix manual about the derivation built-in. A derivation from a Nix language point of view is simply a set with some attributes, right? We've talked about sets before. We said that sets are basically, objects, or not really objects, but, you can kind of consider them similar to objects, where they are just sets of data that have key pair values, essentially, or attributes. So basically what we're saying is a derivation is just a set of configuration attributes, right? And that, when you think about building software, that's a lot of what building software is. It's just like, okay, it's got this attribute of this language, and it's got this attribute of, like, these dependencies. Like, it's all just attributes, right? You're not actually like writing the software. That's the other part of it. This is just what is required to building the software, right? Okay, so a derivation from it. Oh, wait, I read that. Therefore, you can pass the derivation around with variables like anything else, right? That's where the real power comes in, just like as I was saying a second ago. The derivation function receives a set as a first argument. This set requires at least the three attributes, all right? So we have to give it a name, right? Like, what are we building, right? What is the derivation name that we're building, right? The system, right? The system means the archetype, right? So one of the things that's really, really nice about Nix, and you'll learn this a little later, is Nix is entirely multi-arc. And so it can build simultaneously, or it can use the same configuration on an x86 64 machine as it can on a ARM, machine, or some other type of archetype. And actually, to give an example, if I took my dot files, right? Here's a good example. So right now, we were just talking about Nate getting a new macOS MacBook, right? Well, I believe he's got one of the ARM processors, more than likely. Or just in general, if anybody's got any of those, new laptops, they've probably got one of those processors as well. What's really cool about Nix is essentially the way I have my configuration set up. Even if I went across archetypes, like if I went from like Intel to ARM or ARM or something like that, Nix knows how to say, okay, well, I see which architecture that you want me to build for. I'm going to go get the packages for that instead. And so it means that I don't have to really change anything in my configuration, except for make sure that my configuration knows just the systems that it supports. And then once it knows how to support those systems, I can build on any of them at any time and still get the same output, essentially. So that's what's really nice about Nix as well, is Nix is multi-arc. You can basically build derivations on any archetype you want. Builder. It is the binary program that builds the derivation, right? First of all, what's the name of our system as seen by Nix? So let's go into our Nix REPL. And they're saying built-ins dot current system. So if I do that for me, I get back x86 64 Linux because I'm running a 64-bit processor, Intel VM, right? So I get x86 64 Linux. Let's try and fake the name of the system. So we can do D equals derivation, right? And then name equals my name. Builder equals my builder. right? And then system equals, and I think it just says my system. Yeah, my system. My system. My SYSTM. There we go. My system. So if we do that, oh, whoops, hold on. Wait, what am I missing? Oh, wrong side. There we go. Bam. So if we do D, look at that. Now we have a derivation. Here's what's cool though, chat. Look at this. Derivation Nix store. So I created in the REPL a derivation called my name builder my system, right? And even though this is in the language, to show you how the language interacts with the store, if I do ls-alh Nix store and then I literally just copy this copy and paste this path, look at that. It already exists on my file system. When we say that Nix evaluates configurations and then builds them, this is what I mean. I was in the REPL, right? And I made a derivation, a custom one, right? And right after I declared it, Nix went, oh, this is a derivation. Okay, let me go ahead and add it to the file system, right? And so that is where, again, that power really comes into play, where we make these really complex and highly composed modules, right? These derivations, and then we can just use them wherever we want, right? They're completely reusable. Technically, D, right, is a value in our Nix REPL right now, right? It's usable with the language, but what it actually points to is a physical place on my operating system of the path of that derivations build, right? So let's keep moving forward. Oh, what's that? Did it build the derivation? No, it didn't. It did create the DRV, right? And that's what I'm talking about, the DRV file. Nix REPL does not build derivations until you tell it to do so, right? And so basically we've evaluated it, right? But we're going to have to build it. So sorry, I said the wrong word. I meant to say it evaluates it, not builds it yet. Digression about DRV files. So what is the DRV file, right? Like what is this thing, this derivation? What is this thing that is being created from the language directly on the operating system once we start working with it? The DRV file is the specification on how to build the derivation without all of the Nix language fuzz. Before continuing, some analogies with the C language. Nix files are like C files. Derivation or .drv files are the intermediate files like O files. The DRV describes how to build a derivation. It's the bare minimum information. And out paths are in the product of the build. Both DRV paths and out paths are stored in the Nix store, as you can see. What's in that DRV file? You can read it, but it's better to print it. And so we can actually pretty print this if we wanted to. So let's say Nix show, and then let's grab this derivation. Oh, wait, what is it? Nix. Oh, I might actually have to do, Nix show derivation. There we go. And so just like they said, right, this is the specification file that got evaluated once we made it, right? So again, we evaluated just the configuration of a derivation, right? And when we did that, it got added to our store. So when we inspect that from our store, we could see the path of the derivation, the output path as well. We can see the system that it's on, the builder, right? And then the environment as well, which reuses some of those features. But yeah, this is like, if you were to think about this in a better scenario, this would be like using, you know, I don't know, TypeScript or some language to define a variable, and then that like just creates you a Docker file. Maybe not a full Docker file, but like a, you know, like the starting to a Docker file, right? Where it just like, it says like, okay, here's the inputs. All right, we like, that's basically the level of which we're talking Nix works as a build system, that the language literally generates files on the operating system that reference values and variables in the language itself or in the configuration itself. Okay, so we can see there's an out path, but it does not exist yet. We never told Nix to build it. We know beforehand where the output will be. Why? Well, if Nix ever built the derivation just because we access it in Nix, we would have to wait a long time if it was, say, Firefox. That's why Nix let us know the path beforehand and keep evaluating the Nix expressions, but it's still empty because no build was ever made. Important, the hash of the output path is based solely on the input derivations in the current version of Nix, not the contents of the build product. It's possible, however, to have content adjustable derivations for tarballs. We'll see you later on. Okay, yeah. Yo, what's up, Kappa? How's it going? Z as well. What's going on, guys? Hello. Many things are empty in that DRV. However, I'll write a summary of the DRV format for you. So if we look at the DRV format, let's move this over here, and we'll move this off screen for a second. So if we're looking at this here, where'd we go? The output paths, and there could be multiple ones. By default, Nix creates one path or one path called out, right? So essentially, whenever we create a derivation, there's going to be some type of output path. Right, that's going to be the path where whenever we build something, those are the output files from that build. That's where it's going to go, right? So the DRV is what describes the derivation, right? But the actual path of everything is going to be in the DRV's description of out path. Got it? Okay, cool. The list of input derivations, it's empty because we're not referring to any other derivation. Otherwise, it would be a list of DRV files. So if we had a list of input DRVs, as I said before, Nix has the ability of saying, all right, well, I'm going to build something. Now I'm going to use it, right? Not only can it build something, but it can then reuse that thing, right, later on. This is where those things would then go. If we had more DRVs that we wanted to use with this one, we could. The system and the builder executable, yes, it's a fake one, and yes, these are both, or I'm sorry, this and these are both fake. Obviously, builder's fake, my system's fake. And then the list of environment variables passed to the builder, right? And that's literally this right here. That's it. The minimum necessary information to build our derivation. Important note: the environment variables passed to the builder are just those you see in the DRV plus some other Nix related configuration, number of cores, temperature. The builder will not inherit any variables from your running shell. Otherwise, builds would suffer from non-determinism. So that is another thing to consider, is essentially it isn't going to inherit anything from your existing shell when you go to build something with Nix. It wants to make sure that it's entirely isolated, so it can't be impacted by anything. So let's go back to our fake derivation. Let's build our really fake derivation. And so to do that, we can just do the :B in the REPL to build that derivation. So let's go back to our REPL. Move this out of here. Move this over here. And then we're going to do :B, D, right? And this should error. So let's see why it errored. And actually here, we'll look at the error first. So the error itself says, A, my system with features, is required to build derivation, right? But I am x86-64 Linux with features benchmark, big parallel, KVM, NixOS test, right? So basically, when we go to actually try and build this derivation, because this is the configuration, and the system is my system, it's not like an actual system, and the builder's not a real builder either. Well, I'm on x86-64. I can only build technically at the moment for the archetype that I'm trying to build for, and I don't even on this, if I tried to build for a different one, I have no concepts of it, of what my system is, right? I only know what x86-64 is. So this is where essentially it's not going to work, because although you can, basically what Nix is, or what this Nix pill is trying to show you, is you can build for any system and any, builder binary that you want. However, it's got to be supported. Okay, so the :B is a Nix REPL specific command to build a derivation. You can see more commands with : So in the output, you can see that it takes the DRV as the information on how to build the derivation. Then it says it's trying to produce our out path, right? Finally, we get an error that we were waiting for. The derivation can't be built on our system. What we're doing, we're doing the build inside the Next REPL. But if we don't want to use Next REPL, you can realize a DRV with .drv, and we'll get the same output as before. Basically, what we say is we say that to realize, or basically to, I guess, like maybe a better another way of putting it is like to. Yeah, I guess realize probably is just the best way of putting it. But the idea is that this derivation needs to be essentially built again, and an easy way of triggering that, if we wanted to, we could easily just do it directly with the path of the derivation. So we can literally just tell Nix, hey, I have a path to do a derivation you can build as well. And so here, I'll grab this derivation really quickly. We'll go like this, and we'll say Nix store, right, -r, and then I put this in, and we should get, bam, yeah, see the exact same error. So this is also another thing that's very powerful about Nix. Look at this. You can, within the language, execute a build, and then outside of the language with CLI tools and stuff like that, execute a build as well, because we have this .drv file. So that's another, again, neat thing to note about having a programming language with your builds. You have that type of flexibility. Okay, so let's keep moving forward. So let's fix the system attribute, right? And what we're going to do is we're going to say derivation, name, my name, builder, my builder. We're going to keep all of that the same, but we're actually going to use a variable for system. And we're going to use the same variable we used before, built-ins current system. Now, here's what's going to happen, right? Once I do this, I should get a new derivation, right? So my current derivation is 7.3 blah, 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 blah. But as I told you, whenever you make a change to Nix, it doesn't change, it doesn't update the existing thing, right? It creates a brand new thing in that thing's place, or not, and maybe not in its place, but right next to it is what I mean to say. So I hit this, and I do D. Look at that. I have a completely new derivation, I8. So what does that mean? Well, it technically means that the derivation 7.3 is still there, right? And this is where we've talked about having like garbage cleanup and stuff like that, things that we haven't really gone into detail yet, but there are ways of basically saying like, okay, if I don't need this anymore, let's get rid of it, right? But the second thing is to note that, again, once we made it, it's the same variable, right? D, right? We declared D up here for the first one, right? But once we said derivation and we redeclared it, this again, every value in Nix is immutable. So what did it do? It created a completely new version of it, essentially, with a brand new derivation pointed to a whole new Nix store, or a whole new path in the Nix store. And so if I try building this now, right? Now we're going to get past the x86-64 issue, right? And we're going to fail on the builder issue, right? Because as I said before, it's two parts. It's the builder, right? What is the binary that we're building with, right? And then the second part is the operating, or the system, what archetype are we on? And so because we don't have this builder, it once again fails, right? And so I step forward, of course, that my builder executable does not actually exist. And so we stop for a moment. Cool. Only reason you can't set D multiple times is because it's a REPL. You won't be able to do that in the same scope of file. Yeah. It is useful to, okay, so what's in a derivation set? Okay, so we've talked about sets, and you've seen us kind of use these sets, a bit, where we're saying like, okay, well, we want to create a derivation, right? And in that derivation, we're going to pass it the parameter of a attribute set, right? And this attribute set contains our name, the builder we want, the system, but there's a lot more things that can go in this attribute set, or in the derivation set, essentially. It is useful to start by inspecting the return value of the from the derivation function. In this case, the return value is a plain set, right? So if we wanted to, we could actually use built-ins.attr names. Basically, we're looking up the attribute names of a specific set. And then if I do that, we should see all builder derivation or DRV attributes, DRV path, name, out path, out. Basically everything we see, pretty much in the JSON file or the DRV file. But it's, it's showing us in this nice little array, right? This shows you, once you make a derivation, what attributes are in it. You can guess what built-ins is attributes does. It returns true if the argument is an attribute set, which again, we didn't do because we knew it was. While built-in attribute names return a list of keys of that given set. Some kind of reflection, you might say. So if we start from DRV attributes, so if we say d.drv ATTRs, and we want to just see what is the value of d.drv ATTRs, look at this. Builder, my builder, name, system, right? That's basically the input we gave to the derivation function. Also, d.name, d.system, and d.builder attributes are straight the ones we gave as are the same as the ones that we gave as the input, right? And so we can even do a little bit of a check here where we can say d equals d.out. It's the same thing, right? So out is just the derivation itself. It seems weird, but the reason is that we only have one output from the derivation, right? That's also the reason why d.all is a singleton. We'll see multiple outputs later, okay? I know this is a bit to wrap your head around, chat, but I hope I'm going at least at a decent pace to where you're slowly understanding this. Again, what we're doing is we're using a build system called Nix, right? Which has a language and a package manager. So they're two different parts, right? It has a language and a package manager or a store, right? And what these two do is they interop with each other to build software, right? And so there are scenarios where in my configuration language, if I want to build something, I need to generate a derivation for it, right? And so Nix knows how to go, oh, okay, I need a derivation. I'm going to go out to the operating system. I'm going to create that DRV file. And then if I need to, I'm going to build that thing, right? And then I'm going to do it again. 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 And then I'm going to link all these things together. And then I'm going to do it again with a bunch of other things. And I'm going to link those two things together. That is how Nix essentially works in some ways, right? So yeah, we're just looking at it at a very, very, very low level right now. We're not looking at it from like, what does this look like to build a bunch of, like a big thing of software. We're just looking at it as like, what are the main core components of what makes this thing work? Yo, what up, Patota? What's up, Cran? How's it going to you, buddy? Okay, so the drv.drv or the d.drv path is the path of the drv file, right? Something interesting is the type attribute, its derivation. Nix does add a little magic to sets with type derivation, but not that much. To let you understand, you create yourself a set with that type. It's a simple set, right? So check it out. So if I created a set with the type equals derivation, right? I got a derivation. Now, of course, it has no other information, right? So Nix has no idea what to say, but you get the type derivation. It's just a convenient for Nix and for us to understand that the set is a derivation. So does that make sense, guys? Essentially, Nix does have a little bit of what we like to call maybe, I don't know if this would be technically syntactical sugar, because it's really not. But this extra metadata, I guess, or data essentially we'll say that you can add for type casting. And so in this case, I can actually just say, all right, I have an attribute set with type equals derivation, and I can create a derivation. Now, nothing is going to happen here, right? Like nothing is going to happen here, right? It's just a convenient way of being able to tell Nix that this is an attribute set or a set that is a derivation. When writing packages, we are interested in the outputs. The other metadata is needed for Nix to know how to create the DRV and the out path, right? So the out path attribute is the build path in the Nix store, right? And so that's what we were saying, where it hasn't built yet. So this path may exist, but there's nothing inside of it, right? So out path is essentially the actual build path to that specific derivation in the Nix store. Okay, so referring to other derivations, just like dependencies in other package managers, and here's where we really start, like, you know, connecting the dots a little bit on like how it's a build system and really how you can reuse this over and over and over again, right? How do we refer to other packages, right? How do we refer to other derivations in terms of files on the disk? We use the out path. The out path tells us where the files are of that derivation. To make it more convenient, Nix is able to do a conversion from a derivation set to a string, right? So if we wanted to, we could say d out path, right? And that gives us our out path right here, right? And then if we say built-ins dot toString d, look at that. So we can actually get the out path directly, right, in the attribute, or if we wanted to, we could simply just convert the derivation set to a string, and when you do that, it does a little bit of magic and it gives you the path instead. Again, this is what makes Nix very domain specific, right? This is probably not something that you would expect, right? But this is probably something that is very nice to have and very powerful when we talk about referencing other derivations with Nix, right? So I can see why, again, this being something very nice and, you know, again, more like domain specific to Nix than just being like a general purpose language. Nix does the set to string conversion as long as there is the out path attribute, much like a toString method in any other language. Right, exactly. So this would not work if the out path attribute in the set didn't exist, right? And again, that's a bit of a Nix thing. That's not really going to be more of a language thing. So built-ins toString out path foo. So if we go built-ins, right, and we're just kind of showing you how, you know, you can kind of manipulate this, I guess, is the best way to put it. If we say toString, right, we're going to create a set, and then we say out path, right, foo, right? Like it's just, we're just creating a set with out path foo, but we are converting it to a string. So that's the thing to really point here, right? Just to really get this point across of like how this works, right? Is it's taking this set that has out path in it, and when we convert it to a string, it's saying, okay, cool. Well, because out path is here, we'll make that returned string be whatever this is, right? Again, specific to Nix, but it does help when you need to reference things and things like that. So if I do enter with my own out path, you'll see that foo. So it literally, built-in toString literally just looks for out path in a set, and it renders whatever that is. toString does work on integers. Yeah, no, I'm just saying with direction of, or I'm saying with regards to derivations and going from a string to an out path, there, that's the utility here, right? That's the power of saying like, all right, well, if I want to reference a derivation in the language, right, I can just convert it to a string and I know I'll get the actual path to that derivation, which will then be expressed. Okay, so let's keep moving forward. And you'll see here that if we do built-ins dot toString and we create a set of just like A equals B, right, then this fails, right? It'll literally say cannot coerce a set to a string because there's no out path, so there's no other way to coerce this into an actual string value the way that we want to convert sets, right? So essentially the best way of looking at it is we either convert a set with an out path or we don't convert it at all. Make sense? Nix does, oh wait, yeah, I already read that, sorry. So say we want to use binaries from core utils. Ignore the Nix packages, etc. Right? So here's what we're doing now. Now we're actually saying, hey, we want to use some binaries from core utilities, right? Like an actual package. All right, so I really need, like, this is where gonna start clicking, so I need you guys to pay attention here, okay? This is where we start stepping into actually valuably building software versus me just showing you a language and it's like neat little things, right? So we've been messing with derivations, right? We've been messing with derivations, and we have our derivation here that we have created. So if I just do D, right, my derivation in my Nix store is I8 whatever. I want you guys in your mind to think of this as your piece of software, okay? So this derivation is the description for your piece of software, right? Whatever, it could be a JavaScript app, it can be a Python application, whatever. But what I'm trying to make very clear here is that this Nix store path is the derivation for whatever you're trying to build, right? And say you go, okay, I need, core utils, right? Like I need some type of binary to be added to my application so that it works, right? Maybe it's a Postgres, PSQL, maybe it's something else. I don't know. In this case, we're going to use core utils, right? Now, remember, Nix is three things. It is a language, it is a package manager, and it is an operating system, okay? Now, we are going to first lean on the language, right? But the language is also directly integrated with the package manager. So if I do :L Nix packages, I'm going to actually load Nix packages, or the package, all of the available packages within Nix packages available to me as variables. So if I hit enter, you're going to see I have 15,490 variables. Now, this doesn't mean that's all of the packages because there's like 80,000 of them. It just means that in the direct reference of Nix packages as a value, there are 15,490 variables, okay? So if I do core utils now, look at this. I just evaluated the variable core utils from Nix packages, and guess what I got from that? I got the actual derivation for it, right? And so if I needed to now reference this somewhere, there it is. Like that, like literally, there it is, right? That is the derivation for core utils. And so again, if I wanted to, I could say built-ins dot toString core utils, right? And then I get the path of the derivation file, or the build file, or the build path. Sorry, I get the build path or output path of core utils, right? So if we do core utils directly, I get the derivation file, right? But then if I do it as a string, I get the path. Well, what is in this path, do we think? Right? Like, okay, cool. You got a derivation file and you got a path. Like, what's the big deal about this path? Well, the big deal about this path, and is if we read a little bit further, apart from the Nix packages stuff, just think we added to scope a series of variables, which is what I just said. One of them is core utils, right? It is the derivation of the core utils packages you all know from other Linux distributions. It contains basic binaries for GNU Linux systems. You may have multiple derivations of core utils in the Nix store, so no worries, right? However, look at this. If I run this, say I run this over here. I have a ton of different core utils, but look what's inside of it, right? So you might be asking yourself, what's the importance of this path, BG? Well, this path is literally where all the build files are. So when you start talking about like, okay, I want to build a shell that like has references to all these things, you got to know where they are. You know what I mean? And this is why Nix is, again, domain specific, but it's also very powerfully domain specific. If I'm using a language to build software, then I also need to be able to easily rely on that language and find the paths of where these software, or where this software is created, where it's built, and things like that. So a better way of kind of like looking at this is, these utilities are what helps us kind of reference and find where all of these outputs and build files are actually existing. And to give you like a little bit of a spoiler here, what I could do, and Cran's just like chomping at the bit to spoil it before I do, is you could essentially say like core utils, right? And then /bin, right? And then look, anything in bin is where all of your binaries are, right? So I have just now created a path that I can reference to all of the binaries that I need, right? Cran, calm down. Yes, if we want to be technical, we can just do this, and that works the same too. It's string interpolation. However, what I am trying to say is that, again, this is the reason why Nix is really powerful when it comes to not just building a single piece of software, but building lots of pieces of software together, right? You'll see that, again, I loaded in 15,490 variables, and once I had that, I had all of those things available to me that I could use in other pieces of my software. So let's keep moving forward. I will drink. I do appreciate the help though, Cran. Yeah, I do. Yeah. Okay. I remind you, inside the strings, it's possible to interpolate Nix expressions, right? And that's literally what we're doing. So without having to use the built-ins, I can just do string, right? Interpolate D, and then I get the actual path, right? I don't have to do the built-ins thing. So again, if I wanted to refer to the binary true, so for example, if I was like, all right, I need to make sure that I can access the true true binary from core utils, well, this is the path I would create. And then if I hit enter, look, chat, like, if this doesn't blow your mind, I don't know if Nix is something you would be interested in. I'm going to be 100% serious. And it might also be that you're just not getting it yet, and that's fine too. But when we talk about building software, and we talk about needing to know the paths of where that software is created, the dependencies, things like that. Like, this is even a problem with Docker, where you'll build something and then you're like, wait, where was the output path? Where is it in user bin? Is it in user local bin? Like, this solves that problem by simply saying, like, we're going to include the paths with everything. Like, if you want to know where a build is, just interpolate it. Right? And then it'll give you that path, and then say like, okay, if you need a binary from that path, then you just append it, right? You just say like, all right, well, there's your path. All right, bin/true, bam. Now you've got your binary that you need to run, right? And so it's just like, it's super nice because it's a super easy way of using variables to referencing actual paths on the operating system, rather than like, having to figure it out on your own, right? Like, this is built into the language. When you build a derivation, it keeps a record of those paths and outputs and all of that stuff, Just think about that. Think about that, chat. Think about being able to have a variable for your build, right? And then if you evaluate that variable, you get the path of where all of those build files are. You get, its own isolated build that's completely immutable, right? FB Design, what is up? Hello. How are you? These are the type of, like, again, powerful things that Nix can help us with, right? If you had to relearn to code from scratch with zero knowledge, how would you go about it, and what language would you choose? It's a bit of diversion of what we're doing right now, but it's okay. I don't mind answering it. The easiest way I can probably answer that question is I would probably it depends on what I want. Honestly, hard. A big part of what makes your question so hard is that it really depends on what I would want. If I was gonna say, all right, I'm gonna buckle down for the next 5 years and I'm gonna just try and be the best engineer I can be, I would jump on Rust. I would go directly into like Neo. Like, I would throw myself into the most difficult, like, just develop, like, you know what I mean, whatever possible. Why would I learn Rust? Because of what it solves as a language helps you understand why you would like. I think one of the things that like makes people like Rust a lot is actually not the language itself, but just the fact that it does a really good job of contrasting itself to other languages. You know what I mean? Like, you can look at Python, you can look at JavaScript, TypeScript, and even like Go in some regards, and kind of like all be like, you can use any of these, like whatever. And maybe not Go, but like definitely Python and JavaScript and like languages like that, like scripting language are so much more interoperable. But when you talk about Rust, or even Go, right? Or even like, C#, things that give you, like loud, abrupt messages that are just like, hey, you're dumb. And this is why, right? Like, it's one thing to be called dumb by your compiler, but it's another thing for your compiler to then also say, here's why, right? And that's honestly, I think, why a lot of people like Rust, is because it doesn't just like slap you on the hand, but it also tells you why it's slapping you on the hand. You know what I mean? You don't have to like discover that through 9-10 years of using the language. Go is also very similar. Like, Go is very straightforward. It's statically typed, but it's also like, got a lot of the nice things that you like. I guess what I mean to say is I probably would not start in a scripting language. Yeah. I think that's a better way of saying it. I don't think I would start in a scripting language. I think I would be like C# or even C++ or like just something that like actually helps you understand what building like good software is like versus just building products. Like, if you're using TypeScript, JavaScript, even Python, like these 3 languages, or really 2 languages and one like, superset, these languages are only focused on bottom line, getting your shit out the door as quickly as possible. They are not focused on building good software. Rust, Go, again, even some of the other languages that I've talked about, they are focused on building good software, or at least trying to build good software while you run, right? And so I think that would be my biggest thing, is like, I probably would not have picked a language that just got me a job. I probably would have picked a language that like helped me really, really understand it more. Yeah. Oh, you're fine. No, you're good. You're good. Of course. Yeah, no, I always want to make sure I, give people an honest answer. So, yeah. Exactly. Yeah. So like what Linux, I think maybe is they're saying, right? Like, I learned JavaScript, Python, like all those like smaller, like simpler scripting languages before. But I'm not gonna lie, once I got into Go, and again, like, or even just like lower levels like C++, and well, not really C++, but C, even like .NET and stuff, like C#, like, that's when I was really like, oh man, like, this is what compilers are used for, and why we have static typing. Oh my gosh, this is incredible. You know what I mean? Like, your perspective changes. It definitely, like, it changes quite a bit. So like, yeah. I'm learning from FEM. I completed CS, CSS and functional programming full now React, but I have a doubt for front-end interviews. Will they ask system design? No, they're not going to ask you system design questions in front end. If they are, you're probably like going for like a principal engineering job, or like a staff engineer or something like that. If you're just like, new to front end, or, just a normal front end job, they're probably not going to ask you on anything like that. You know what I mean? I got asked what a mutex is on a front end job. Honestly, if you knew what a mutex was, I would immediately say, why are you asking me? Like, that would be my response, is like, because I would genuinely be like, okay, why are you asking me about mutexes? You know what I mean? That would be a bit of a red flag to me if somebody asked me that for a front end job. Yeah. My first language was Python, and C program became a lot of fun to learn C. Yep. Yeah. I did read that though, but If you ever avert code in scripting language, you can never learn another language. I'm a Python developer for 5 years. I'm struggling learning Rust or Go. That's so hard for me. But that's good, honestly. It's good that you're throwing yourself into it because it means that you're realizing as a developer you've been using, like, crutches for a while. You've been using a handicap for a while. Like, that's the easiest way to put it. You know what I mean? And I'm not saying that Rust, JavaScript, or TypeScript are, like, bad. I'm just simply saying, yeah, like, it's not meant to be as strict. Right, and that makes it easier to build software that could be more troublesome. We're not talking about just building software quickly. We're talking about building software that's not troublesome. And as a matter of fact, this literally goes back to Nix as well. Like comparing, again, something like Nix to Docker. Even like Docker's great. Honestly, Docker is the JavaScript and TypeScript of like the build world. It's used everywhere. It's very easily usable. Most people like have their own way of doing it. You know what I mean? Like that's my point. Is this like Docker's not bad. It has a seriously awesome, powerful tool, or it is a seriously awesome, powerful tool. But like when we look at like look at what Nix does, right? Docker at the bare minimum has like a simple DSL. Right, with its Docker file or domain-specific language with its Docker file, and stuff like that. But it's like it's meant to be simple, right? It's meant to be like the DSL in Docker is like 9 words. You know what I mean? It's like literally like 9 words. Compared to like again a much more larger domain-specific language with Nix, it's like creating a it creates, you can create variables with it and pass those variables and parse those variables and have sets, and that interacts with like a the actual file system and creating you know what I mean, like it creates physical representations of files, you know what I mean, or of builds and things like that, and variables, and like it's when you compare the two you could see the benefits, right? And I think that is really what happens with like stricter languages. You just start to see see the things that aren't there, right? You just start seeing the things that aren't in other languages, and you go like, okay, I really like this, or I really don't. You know what I mean? What's up, Neochromer? By the way, how's it going? Hello. What does Golang have that TypeScript doesn't? Static binaries. There's one. Static binaries that do not require you to ship your packages with your actual code, or with your actual distributable, I should say. Yeah, I hate that. Honestly, my life, I've probably lost a solid 6 months of my life over my career of simply just figuring out how to get packages with their source code. Yeah. Hot take, static binaries are overrated. Shut up, Jordan. Just shut up. Just shut up. I ain't got time for you today. All right, just shut up. just shut up. I'm just kidding. What's up? Shout out to Vape Juice Jordan. If you guys don't know, the wonderful, wonderful person. Oh shit, yo, Queb, what up, dude? Dude, your text is so light. I like barely missed it. How long is that TRRS cable, and where'd you get it? This guy? You talking about this right here? This came with my keyboard. Who cares about static binaries when you have a container? Okay, so Jordan, here's what I'm gonna say. Here's what I'm gonna say to you about that. All right, and I'm gonna be clear. I only accept that if the person writing the Docker file knows what the they're doing, all right? That's all I'm going to say. Because you know as well as I do, you can have a 5 gigabit inflated Docker file that just sucks. But sure, you're not wrong in what does containerization solve as a problem, yeah. Yeah, it's just wound in the middle. Yeah. It just, oh, I see. You thought it was, yeah. Knowing a Docker person to know what they are doing is too... I mean, yeah, it sucks. You know what's funny, chat? I'm guessing I'm talking about apps. For shit like CLIs, Yeah, so here's in like here, and I will say this hands down. Yeah, I agree. Oh yeah, for sure. Okay, I think a better way of saying it is for shipping like hosted software, right? Like basically anything that is really going to be, running in the cloud or running as a container, Docker's great for. Services, right? Stuff like that. Like I agree fully actually on that one. Like yes, basically if it's a service, Docker's, great for it. What I would probably do is I would probably build a Docker container with Nix and then, put that. And again, you get the best of both worlds. But yeah, no, Nix can't compare to that. Nix doesn't do true container. Like it does, but like, I don't feel like arguing with Cran about it for like 20 minutes on why it's, whatever. But yeah, no, like I a service containerizations, yeah, it's a much easier thing. No, I know you are. I'm just giving you a hard time, Cran. Dude, Owen, thank you for the 5 months. Yes, we've already gone over this, yeah. You know what I love? Docker on Mac. Jordan just chose violence today. I feel like you normally choose violence, though, Jordan. Hey, Jordan, do you think I could convince Meiston to go complete Nix? Because then then we might have a conversation on our hands. Name a better piece of software than Docker on Mac. So fast, so smooth. Yeah, it's unfortunate how bad Docker for Mac is. You can always try. Yeah, that'd be cool, man. That would be game changer. That would be fucking insane. I'll go full Nix for you, BG. Hell yeah. I mean, we'll get there. Don't worry. We'll get eventually we will get everyone converted to Nix in some way, shape, or form. At some point in time, everyone's gonna try it at least once, and I will be proud to say that. Hopefully, we were a spawner of that. All right, so let's keep going forward. Let's keep going forward here, okay? All right, so in the previous attempt, we used a fake builder, my builder, which previously does not exist. But we can use, for example, bin true, which will always exit 0 with success, right? So let's do that. Why don't we use a builder that actually works, all right? So we've already loaded Nix packages, so we're going to create another derivation, right? Derivation. Now, like, the easiest way to describe what I'm doing right now, and Jordan or anybody else who's like interested in Nix or potentially, to give an idea for, like language aficionados or whatever, the main thing I'm doing is I'm creating a variable, right, that represents a build configuration, right, a derivation, right? And so, for example, if I was like, all right, I want my derivation to be my app, right? The builder, in this case, I can give it as core utils. So say I want to do core utils, bin. And look at this. Look. I'm literally using the value, right? The value core utils to declare and set up the path, right? So I'm simply just saying, hey, builder, use core utils bin true, right? And the last thing I'm going to do is I'm going to say system equals built-ins dot current system, right? Now, when I do this, it's going to generate a file on my operating system, right? You can kind of consider this as like your Docker file, kind of, right? This is like the actual thing that sits on your operating system. Well, this isn't the Docker file. This is more like just metadata for the Docker file. But this sits on your system, and this basically says, hey, this is something I'm going to build, and these are like the attributes for it, right? But the main point here is that when we declare a derivation in the language, it interacts with the operating system, or it interacts with the package manager to actually like render files, or not the package manager, the store. It interopts with the store to actually making and rendering these files physically to the machine. So like if I was to do ls-alh on this file, we'll see that it already exists, right? And if I was to do nix show derivation, right? Like I just made this in the REPL, but look, name my app, right? Builder. Look at this. It's pointing to the Nix store, core utils, right? And this is where we say like, hey, we need an input of a different derivation. Like, I really need to figure out a better way of showing this, because the easiest way of describing this is all of these builds are just variables now, dude. And like, it's just insane how easy it is to pass around these and kind of like build your software with this language. Because now if I wanted to actually build it, for example, right, BD, I'm literally building it, right? Now it failed, which is fine, because the builder not actually create a path. It just exited with 0, and that's what it's saying here, right? But again, like, programmatically declaring your package configure or your build configurations, reusing those programmatic values within a language so that you can compose and abstract other builds and putting them, like, I gotta figure out a better way of doing this because the power here is just like insane. It really is insane. And that's why we're going through this pill series. Okay, so another step forward. It executed the builder, right? But it did not create a path, right? So obvious note, every time we change the duration, a new hash is created. And we've already talked about this as well. So let's examine the DRV, which we've already done. And, you know, they basically exemplify the same things I did, right? And look, Nix added a dependency to our my name, or in our case, myapp.drv, which is the core utils derivation. Right? We used the core utils derivation as a variable in our configuration or in our attribute set, right? Core utils bin true. So what did Nix do? Right? Nix actually said, well, hey, I'm going to take that value. I'm going to translate it to the path so that we can actually reference the real path. And then it said, well, hey, because this is a DRV, I'm going to make sure it's in the input DRVs set, right? And so yeah, that's basically Nix saying like, okay, I see that you're using a derivation of a different piece of software. I'm going to include that, right? So Nix does not, all right, 6.6. When is the derivation built? Nix does not build derivations during evaluation of expressions, okay? So in fact, that's why we do a BDRV in the Nix REPL or use the Nix store-r in the first place. So that is something that I was using the wrong word in the beginning of the stream or earlier on in the stream, and I do want to be fair, I was using the wrong word. When we evaluate, right, an expression, we're evaluating it. We evaluate it to our store, essentially. That's probably the best way of describing it is when we evaluate a Nix configuration, we essentially generate this, right? We evaluate it, or we basically say like, okay, we're going to instantiate it, and it now exists as something that we can build on our computer, right? That's the first step. Once we evaluate it, it exists in our store as something that we can build. But Nix is lazy, right? It's lazy loading essentially everywhere. And so it doesn't actually build it until what we call realize it, or we actually execute that build time, right? And so this is where, like, you know, I think I really like Nix a lot, because if you were to compare this to like Rust, we're taking a step away from normal terms and we're trying to describe more accurately what we're doing. And I think Rust actually does a pretty good job at that too, where, you know, it focuses on the naming of what it's doing to more accurately describe the action, right? Because sometimes one word can mean two different things and then you mistake them, right? So again, the instantiation or the evaluation time is when the Nix expression is parsed, interpreted, and finally returns a derivation set, right? So again, before you can even work with any type of pre-existing derivation, you need to evaluate it, which then creates this DRV that you can then use, right? During evaluation, you can refer to other derivations because Nix will create DRV files and we will know are the out paths beforehand. This is achieved with Nix instantiate. So the reason why we do evaluation is not just because we might have to evaluate one package. It might be because we have to evaluate a ton of packages. And so we go, we pull the initial derivation, right? And then we see, oh, there's a ton of other derivations in there. So let's create all of those too, right? And so then all of these get created as well, right? For all of these other derivation dependencies, essentially, that we have. And then finally, once we've instantiated or evaluated, that's when we say, like, okay, well, we can realize or build it, essentially. And I think the term realize is really good here because it's an instantiation and then a realization of that instantiation, or an evaluation and then a realization of that evaluation, right? And the realize or build, essentially, meaning here is that we are taking that set and we are bringing it to life, essentially. We're actually making it into the thing that it's supposed to be, which is, again, why we say realize or build, right? So think of it as a compile time and a link time, like C and C++ projects, right? You first compile all of your sources to object files, and then you link those object files into a single executable. Nix essentially, works the same way. In Nix, first the expression, usually a .nix file, is compiled to a DRV, right? And as I said before, those DRVs exist where? They exist in your Nix store, right? So once they're in your Nix store, then each DRV is built and the product is installed in the relative out paths, right? And so that's why these DRVs have out paths, because it also says, all right, well, not only is this the DRV, but this is where the out path of, this DRV or this derivation is going to be built. This is the out path of where this one's going to be, and it links it all together and makes it so that everything knows where everything is, right? Conclusion, wait, what time is it, by the way? Okay, we're good. Is it that complicated to create a package for Nix? No, it's not. We're walking through the fundamentals of Nix derivations to understand how they work and how they are represented. Packaging in Nix is certainly easier than that, but we're not there yet in this post. More Nix pills are needed. With the derivation function, we provide a set of information on how to build a package, and we get back the information about where the package was built. Nix converts a set to a string when there's an out path. That's very convenient. With that, it's easy to refer to other derivations, right? And so basically what we've got is we've got tons of sets, right? Just tons of sets that represent derivations. And then whenever we whenever we convert those sets to a string, we get the out path of each one of those derivations, right? And then that makes it really easy to refer to each other. When Nix builds a derivation, it first creates a DRV file from a derivation expression, right? That's that first instantiate or evaluation part, right? And it uses it to build the output. It does so recursively for all the dependencies, right? All the inputs. It executes the DRV file like a machine. Nothing magic after that, right? So I just showed you a derivation that really had no dependencies, right? Its own custom builder, its own custom system, its own custom name, right? And then we said, okay, well, that derivation really gave us nothing, right? So let's try leaning on something that maybe already exists in Nix, right? And so that's when we said, like, all right, now what we're going to do is we're going to create a derivation, same name, but this time we're going to pass it a different builder. As a matter of fact, we're going to pass it a builder that references a different derivation and the path inside of that derivation, right? Or that build output of that derivation. And so what happens is builder evaluates core utils to the full path, right? And you can see here, it's right here, right? And then it appends /bin/true because this is the actual binary I want the builder to be, right? And then we tell it system current state, right? And so, as I said before, that's what really makes this variable, conversion so powerful is you would not imagine that with, really one line of code, you could generate so much metadata about a build. But if you think about it, like, look at this derivation. All we're giving it is a name, a reference to another derivation's path, build output path, and then system. And then it's able to, say like, okay, well, this is where our actual derivation is. Here's the output for it. Here's any inputs it has. Here are the link, or here are the paths to those inputs, right? Like all of this stuff is just auto-generated and metadata already exists, right? And that's what it means by it does it recursively. It can literally look through every derivation and say like, okay, let's build everything until we get to where we need to be, right? The next pill, we will finally write our first working derivation. Yes, this post is all about our first derivation, but I never said it was a working one. That's pretty good. That's pretty good. I appreciate that. That's pretty good. Okay, so here's what I want to do. That was a lot. That was a lot, right? And the TLDR of looking at our first derivation was really to get you guys to understand how the language interacts with the build process and how we create these derivations with these sets and basically make it so that, when we go to actually instantiate something, right, it's able to find all the paths for us, find all of our dependencies, and wire up this nice configuration for us, right? And then when we go to build it, right, it's already got all the paths in place. It already knows, like, so we've really just shown you how it works, right? In the sense of the technicals. Now what we're going to do is we're actually going to work with a working derivation, and we're going to, we're basically going to actually, hopefully build something, right? Build something of some sort. I am going to take a super quick break though, okay? Because I've been going for almost 2 hours. So let me take a super quick break, and then when I get back, we're going to jump back into this, okay? So yeah, while I'm taking my break, if you guys are new to the channel, again, please be sure to check out that little blurb about us, basically where it co-hosted stream by myself, BG, as well as my good friend Atoda. We also have YouTube, so we are working on we're working on building out our YouTube. A lot of this stuff in the YouTube that we're trying to get out in the near future here is going to be focused around a lot of the stuff I'm literally doing on stream now, Nix and automation and cloud infrastructure and a lot of these other things. So please sure to subscribe to the YouTube. The second YouTube link is actually our archives. And this thing is getting updated a little bit more often right now because it's easier. It's just our VODs. But if you ever miss anything, if you ever want to catch up, this whole series, by the way, will be in the archives. It's not going to be on. It's not going to be on the actual main page, but it will be in the archive. So if you guys want to go back, God, I almost knocked over my coffee. If you guys want to go back, did you see that, chat? Oh my gosh, the universe was nice to me. If you guys want to go back and see any of these other VODs, be sure to check out the YouTube. We also have a fantastic community in our Discord. If you guys are new to any of this stuff, whether it be DevOps, infrastructure, Nix, whatever, we have a great community that is willing to help you out. We also have dedicated sections in our Discord, whether you want to ask about DevOps, Nix, or really anything else. So yeah, feel free to join that as well. And then we also have social media. So if you're interested in basically seeing me fail at Twitter, you're welcome to follow us on Twitter. Okay, so I am going to take a super quick bathroom break, though, and then when I come back, we will jump directly into working derivation, an actual working derivation. I've never went through the Nix pill, so I'm actually enjoying this a lot. No, I am too. I'm actually very happy that we're doing it. I really am, because as I said, I am making a video right now on basically what Nix is. And this is helping me, I think, know how, like I said, my biggest problem right now is not technically understanding a lot of how this stuff works. It's like showing the value, right? And I think a massive value for me, right, is really being able to lean on Nix's language and metadata and again, it may be domain specific, but the way that it focuses on the problems that it tries solving, and again, this whole string or set to string thing and how you just get the path out of that, it's so nice. You know what I mean? It's really cool. There aren't as many things like that with other build systems, so yeah, I'm really trying to identify the value that we get, you know. I really need to learn DevOps since it's like inexistent at my honestly, DevOps is pretty inexistent in most places. So don't feel bad. Or if it is existent, it's not really well represented. I would say, yeah, I would say it's not really well represented. So, all right, I'm gonna take my break. I will be right back, guys. I will be right back. I'm gonna run an ad during my break as well. So if you guys don't know why we run ads during our breaks, it's basically so that you guys don't miss anything. If you are subscribed to the channel, if you'd like to be subscribed to the channel, you will not get an ad. Also, if you have Twitch Turbo, you will not get an ad as well. All right, guys, I will be right back. Thank you for being so awesome. And when we get back, we will jump into a working derivation. All right, give me 1 second. All right, chat, I'm back. Let's do this. I'm going to exit out of this REPL really quick. Thank you guys for sticking around. I appreciate you being, you know, kind enough to let me use the little coder's room. Okay, so let's make our first working derivation. So again, remember, in the 6th pill, we introduced the notion of a derivation, right? But we didn't really do anything else. Like, we just did a raw derivation and just how to try and build it, right? We didn't actually build anything. Lurking around. Listen, man, all you got to do right here, exclamation mark lurk, bam, look at that. And we appreciate you. All right. So using a script as a builder, what's the easiest way to run a sequence of commands for building something? A bash script. So obvious, right? We write a custom bash script and we want it to be our builder. Given a builder.sh, we want the derivation to run bash builder.sh. Now, we don't use hashbangs in builder.sh because at the time we are writing it, we do not know the path to the bash in the Nix store. Yes, even bash is in the Nix store. Everything is in there. And if I do where is bash, look at that. Bash is in fact in my Nix store. Everything in Nix is in the Nix store. Just to be clear, right? We don't even use user env bash or user bin env because then we lose the cool stateless property of Nix. Not to mention that path gets cleared when we build, so it wouldn't find bash anyways, right? In summary, we want the builder to be bash and pass it an argument builder.sh. Turns out the derivation function accepts an optional args attribute, which is used to pass option or arguments to the builder executable. So first of all, let's write our builder.sh in the current directory. So what I'm going to do is I'm actually going to create a new directory, say 07, right? And then we'll say declare XP. I am checking every single one of these environment variables to make sure I did just not echo something I should not have. Hang on. Yeah, it does look fine. It does look fine. Cool. I just had to be sure. I had to be sure. List exported variables. As we are covered in the previous code, Nix computes the output path of the derivation and then echo foo out. Yeah, I mean, I don't, but I just didn't know if I had anything in here. So wait, so I'm doing declare XP and then I'm going to echo foo out. Yeah, I'm not going to lie, I don't fully understand. Oh, this is in the file. Okay, sorry. Okay, I was confused. Okay, so we need to create a file called builder.sh. Okay, I was super confused. Declare XP, right? And then echo foo out, right? First of all, let's write our builder.sh in the current directory, right? Yeah, so that's what we do. So we do declare XP, and then we do echo foo out. The command declare XP lists exported variables, declare as a built-in bash fund. As we covered in the previous build, Nix computes the output path of the derivation. The resulting DRV file contains a list of environment variables passed to the builder. one of these is out. What we have to do is create something in the path out, be it a file or a directory. In this case, we are creating a file. Excuse me. Okay, so I'm not gonna lie, I'm kind of following what's going on this one. So yeah, like I'm with you guys on this one. I'm a little bit like, wait, what's happening? So essentially what they're having us do right now is they're having us create a builder.sh file, right? And in that file right now, we've created 2 lines. The first one is declare.xp, which is just listing exported variables, and then echo foo to out. Essentially, we're echoing foo, whatever foo is, to the directory or the output path out. Whatever this is, I don't know what. Like, I know I've seen this before in Nix. I do not know how this gets declared though, so we're gonna figure that out. What we have to do is create something in the out, in the path out, right? So yeah, so basically we're echoing foo into the path out. Be it a file or a directory. In this case, we are creating a file. Okay, so basically what's happening here is our builder.sh. Why are we like listing exported variables? I don't fully understand why wait, hold on. The DRV contains a list of paths to the builder. One of these is out. Oh, okay, I see. So we're just showing it here as an example, but we're actually using it here. Okay, I see. I see. Okay, so let me rewind here, chat, just so that we're fully caught up, because now I understand what's happening. We're gonna make a derivation just like we did before, right? However, this time we're gonna create our own builder with a builder.sh file, right? In this builder.sh file, we're using declare.xp just to show all of our current bash variables, right? If I really wanted to, I could also just do this. I could also just do echo out, right? Which I'm going to do just to be a little bit more safer. But that's going to show me the out path, right? And then what we do is in the second line, we actually echo a file called foo to out. What does that mean? That means that our builder technically built foo and echoed it into the out path, right? And so now, let's see, what we're going to do is we're going to look for, I guess, core utils to get the actual bash pass or bash path. Jeez, there we go. Okay, so we're going to close this out really quickly. We're going to go to Nix REPL. Here we go. We're going to load Nix packages, right? Nix packages. And then we're going to look for bash. And look at that. Bam. That is the path to our bash derivation. Now, what did I just do? To be clear, what did I just do, chat? Well, I opened up a REPL and I loaded Nix packages, right? I loaded Nix packages, or the actual Nix packages manager, where all of our existing programs live, right? Bash, Go, NeoVim, whatever. They all exist in Nix packages. So I loaded the variables where those exist. And then I said, okay, I want to find the derivation path and evaluate bash, because I want to use it and I need to know the path for that, right? And so what happens is once I evaluate this or initialize it, right, it gets initialized in my store with this path that I now have available to me, right? And so as it says here, right, with the usual trick, we can refer to bin bash to create our derivation. So if we're going to try creating a derivation with a bin bash as our builder, we say d equals, right, new set. Oh, sorry, derivation. New set. Name equals foo, right? Builder equals bash / bin bash. I might have to reload Nix packages. I think I closed the REPL. Args, right? Builder.sh system equals built-ins built-ins dot current system. Right? So let's look at this before I run it, okay? So I'm going to make a new derivation, right? This is going to be our first attempt at a working derivation. And it's going to be named foo. The builder is going to be bash, which I just loaded as a variable in a few lines ago, right? Where I loaded Nix packages, and then we evaluated bash itself from Nix packages. And then we're going to pass it the args of builder.sh. Right? So it's actually going to take the current path. Excuse me. It's going to take the current path, and then it's going to run the builder.sh file that we have in that path. And then it's going to say it's going to run it for the system of our current system. Again, system is just telling it the archetype because Nix can run on multiple archetypes. Yeah, I don't want to render my whole bash environment. That's basically why I'm not doing that. If you're interested in the music, by the way, it's just playlist. Oh, that's right. It does. Yep, you're totally right. Okay, hold on. Yeah, you're right. Okay, it is safe. I forgot about that. It's sandboxed. 1 second. Okay. Declare XP. Right? Right. Yep. Cool. Okay. Awesome. Okay, so let's go ahead and create this derivation, right? Bam. And then if I hit D, right, there's our store. Now, before I build this, do you know what I want to do really quickly, chat? Just because I'm comfortable with this a bit. I'm going to show this derivation. I want to see the configuration, right? Let's take a look at it, just like we have in the path, or in the past. Sorry. So what do we got? Well, when I evaluated our derivation in the Nix REPL, remember, chat, the Nix language works directly with the operating system. Like, I guess the easier way to put it is like the language uses your operating system as a data storage, right? So when you create variables to things in the Nix language, those are sometimes, not always, but sometimes represented by physical files in the actual operating system, in the Nix store, right? So when we created a derivation with the variable D, right, we made it a new derivation with the name foo, the builder bin bash, the args of builder.sh, and the system that we want it to. That was created as a .drv configuration file, essentially, in our Nix store. So I can, like, before even building the software, if I want to be like, all right, how can I make sure that like all of the inputs are there, and like it's resolved, like now that I know what I'm trying to do, how can I verify what I'm doing is proper or possibly right before I like move forward, right? Well, this is, again, and I'm like, honestly, I'm saying this to you as I'm learning this. So don't think that like this is something I do. This is something I'm going to do a lot more now, because it could save a lot of time on your build process. Like if you need a specific derivation or something like that, and maybe you're injecting it improperly, you could show it here without actually having to build it and then like have it fail, right? And so that's kind of what I want to do really quickly is we just built this we initialized this derivation, right? We evaluated it. Again, those words are kind of interoperable there. Let's take a look at what the DRV file created for it was, right? So here's the path. Here's the output. So that's where, so essentially we should be able to, and look, I'm going to predict the future here, chat. I should be able to do this. You see how this says no directory? If this is our out path of this derivation, then that means that when my builder script, right? My builder script right here, when it runs, it's going to echo it into this path with the file foo, right? So right now I can, it's a file, not a direct. Yeah, no, I know. I'm saying, wait, so you're saying that this is a file? Because, I mean, my point is still right. I just am wrong. Okay, cool. So, okay, my bad. I didn't know if it was going to put it in a file or if it was going to create it as a file. Wasn't sure if that was the case. Okay, so if you're rendering it as a file itself, then yes, it will just be the file as Cran is saying, right? So even if I do this, we'll still see no file or directory because I haven't created it yet, right? That's the TLDR. My output path has not been created yet because I haven't built it, whether it be a file or a folder, but that's a good call out. I appreciate that. I wasn't sure if it was literal or if they actually like put it in a folder no matter what. Cool. So as you can see, I've not built this yet. I've just evaluated it. I've just instantiated it, right? So let's look at the rest of it. So input sources, builder.sh. Okay, yep, that's an input source, right? Input derivation, bash. Okay, cool. Yep, that's the bash I needed. System x86-64. Yep, that looks good. Builder is actually pointing to bin bash. Cool. All right. So the builder's looking at the actual bash binary now. Awesome. The args is going to be the builder script, which is now in the store as well. So that means that it's going to, excuse me. That means that it's going to run this essentially in front of this. Yeah. So that's basically what that's going to look like, right? And then here's the environment as well as the args, right? So we've got our args, which is our builder script, which is passed to bash. And then we have our environment variables, which is added to the environment. Okay, cool. So again, I want to be able to test this theory by saying that right now, since we haven't built anything yet, we're not seeing anything in the output for our store, but let's go ahead and actually try building it now. So we're going to say B, D, we're going to hit enter. So check it out. This now says this derivation produced the following outputs out, and then we get a path, right? So what happens if I do this? Hey, look at that. So if I wanted to, you know what? It's an empty file because I just catted it. But that does show you that essentially by us doing the build step and being able to confirm that, again, the output path would be where it is, bash would be where it is, all that stuff, it was able to build it. Cat it? Oh, okay. Does it actually have something in it? I don't know. Let's see. Cat. Foo. Okay. Well, it's just got foo in it. Yeah. Oh, I echoed foo into it. You're right. You're right. I echoed foo into it. So there you go. So I actually have a file built with foo. And so when we talk about the build system, right, it's very easy for us to say like, all right, well, I want to create a derivation. Here's my builder. Here's my args. Here's the system I want to build it for. Go. Right? And then it knows how to automatically set up the folders for you. It knows how to set up the paths. It knows how to link the dependencies you need for it, right? All of this, like just what I have shown you here, even just what I have shown you here should be a really good example of, you know, how this build system, when it actually builds something or puts something somewhere, essentially how it works, right? And so again, what did we do? We leaned on the fact that the Nix language, when you create a derivation with a set, right, it automatically knows how to create these configurations for you on the file system and link all these other derivations together and make sure that they're all available to you in your path, right? It knows how to do all of that. What else? It also knows how to evaluate that and build it and like echo it into the store properly so that when you say, okay, I want to actually build this, it goes to this specific path, and it's a predictable path that other things can then rely on as well. Hey, Melody, thank you so much for the raid. How's it going? Welcome, welcome, everybody from Melody Dev Stream. Thank you, Melody. I appreciate it. I am BG. If you don't know me, hi. I'm one of the co-hosts of the Alta 4 stream. Today, we're working with something called Nix. I'm actually breaking down a series that is kind of like a guide for getting started with Nix, but the TLDR is it's a way of building software, and so it's kind of like Docker, kind of a little bit, solves similar problems, but not entirely. So, welcome everybody from Melody Dev Stream. How are you? Hello, hello, Rascal. What's up? How's it going? But right as you guys got here, I was actually just explaining, which is something that we tried, and I think the easiest way I can kind of catch you guys up is. If you think about Docker, for example, right, you have this concept of like a Docker file. And in this Docker file, you have like inputs and like all these other things. With Nix, it's essentially that same kind of idea. but it uses a much more, I would say, fuller built and fuller featured language to do it, which is actually the Nix language itself. Nix is three things. It's a language, it's a package manager, and it's an operating system. And each one of these, language works with the package manager to build software, and the operating system allows you to use the language to configure it, to then put that software inside of it and run it the way you need it to. And so that's what like the whole Nix everything is. And so if you guys are curious about it, if you guys are just here, there you go. There's a little bit on it. But yeah, we're going through this series called the Nix Pills series. And the idea here is that every one of these pills is just like a further learning that we take with learning how Nix works and stuff like that. And so I have been going through that. Excuse me. And so yeah, that's basically what you are just now tuning into. Cool. Okay. And again, Melody, I hope your stream was good. Feel free to let me know what you were up to. I'm always interested. Okay, so as I just said, we basically created our very first Nix derivation. Now that's one thing that's different from like other build and package managers and stuff like that is that these are called they're just changes. They're just changes of changes of changes, basically. Anytime you have an update, you just get a new build. You don't really like change or add something or remove something. It's just a new build added, and then you link to that new build and you can use it. Was working on learning Laravel. Oh, nice. Very cool. How are you liking that? I've actually never really used that. I've always been able to avoid. I think is that Java? I can't remember if that's Java or not. No, it's PHP. That's right. That's what it is. PHP. Yeah, no, I've never had to use Laravel. That's right. Oh man, I haven't used PHP in a minute. How are you liking PHP? What made you want to get started with PHP? Man, that almost makes me want to mess with it now. Just because like it's been so long. That's exciting. I'll have to stop by and check out some PHP. It's been a minute. Cool. Okay, so as I said, we did it, right? And so when we look at the actual contents of what we wanted to build, right? And again, we even compare it to something like a Docker file. You can see that it's much more programmatically focused. And so if I was to try and compare it, this line and a half here is literally the steps we're taking to building our software with Nix. And again, with Docker, it's like a Docker file. Well, with Nix, it's a language, right? So you're actually like creating variables and building those variables in the language. And so what we're doing here is we're creating a derivation, right, with an attribute set. And again, this derivation is really just going to be a build at the end of the day. And we've got the name of it, the builder, like basically what is going to run the initial binary. In this case, it's just bash. args is a builder.sh script that we're going to provide to it. And then the system is the system we want to build it on. So again, we can build it on ARM, we can build it on Intel, we can build it on all different types of archetypes. We just have to be able to provide which one we want. The cool thing about this is when you talk about like Docker, it's all imperative. So you have to go in, you have to like add these steps manually. But because Nix is essentially declarative and it's based off of like attributes and configuration and stuff like that, this really generates that initial kind of like file for me, right? Now, I still have to write the configuration in Nix, but it will then go ahead and if we go and look at this file, and we were doing this right before you guys got here, if we look at this file, we can actually see that in it generates a whole bunch of like metadata for us, right? So again, this is a value that's just a variable in the language that because I told it was a specific type of value, it's a derivation in this case, it actually used my operating system as a data storage and then created a metadata or a set of metadata essentially of the build that I want to make, right? And so this is where we're talking about like tying a language with a build system where now I can start actually like having abstractions and all of these different type of compositions and essentially rely on the language to do it, and then Nix itself will then lean on all of its like tooling and automation to actually build it, right? And so what I'm trying to create is a application called, or a derivation called foo, right? .drv. Its output path is going to be here, this path, right? It has some input sources, which is the builder, the script that I created, and then the input derivation, which is bash, which is basically another piece of software that was built by Nix somewhere else that I want to be able to reference. And so then we have our builder, which is literally the reference derivation output plus the path to the binary I want to run. So this is kind of like, user bin env or whatever it is. And then this is our args, which is that same input source, right? This is that builder script. And then we've got our environment variables for that build in particular. And so when we evaluate that, when we actually, when we build it, right, or when we realize it, you'll see that it says this derivation produced the following outputs, and then we get a path, right? Well, that path matches the predetermined path that we already had in our derivation. So if I do ls-alh, that path, we can see now I have a file that exists in that path. And if I cat it, right, we could see that it actually says foo in it, like I cat in my builder script. And so, for example, if I go to my builder script, z script, right, boom, here it is, echo foo into out, right? And out is a special environment variable that Nix adds to the environment when it actually goes and builds the software, right? And so that's why we say that Nix is domain specific, right? Where the language itself is not meant to be a general purpose language. However, the language is meant to be specific in a way where it helps you build software within the Nix ecosystem. Let me catch up with chat. Just got a new job that oh, nice. Very cool. Well, congratulations on the new job. I hope you enjoy it. I hope you do. Are you going to be are you just building more like front end focused stuff, or is it like internal tools, or I guess like what kind of stuff are you going to be working with, if you don't mind me asking? I mean, I understand it's Laravel and PHP, which is interesting. That's why I'm interested in what kind of sites they are, I guess. But yeah, congrats. So we'll see here that another note that they're going to say is that we used /builder.sh and not like a string, right? If we give it a direct path without a string wrapped around it, then it gets parsed as a path, and Nix will perform some magic to basically import it and add it to the store and stuff like that. If you use the string version, Nix cannot find builder.sh, and that's because it tries to find it relative to the temporary build directory. Praise, thank you for the follow. I appreciate that. And all of our new follows today. Thank you, guys. And that's very true, right? If we say a path without quotes, then it will know how to actually import that and use some magic so it's usable in your build. Otherwise, if you just use it as a string, it won't fully know. So let's talk about the builder environment really quickly here, right? There was some magic that happened underneath the hood. Yo, Control Squid, what's up, man? How's it going? Yep. I'm actually just trying to get through this pill really quickly before I have to go. So the builder environment, right? Let's talk about a few things here. Home is not your home directory, right? And homeless shelter doesn't exist at all. We force packages not to depend on home during the build process. So realistically, like there's no home, there's no relative path or anything like that in the sense of that already exists on your computer. In the build process, it really wants to separate that so that these builds can be, again, completely the same everywhere. Shixie, thank you so much for the tier 1, man. Thank you. I'm glad you're enjoying the content. I appreciate that. Thank you, man, for the first of hopefully many subscriptions. And again, thank you, man. We really appreciate that. All of like everything you guys help us with, again, we give right back to what we do here. So just know that will probably just go to our Amazon cloud costs. Yeah. Thank you. Which is just going right back to Jeff Bezos anyway. So it's like, man, what can we do? Monopolies don't exist though, right? Well, I'm glad, Chixie. I'm glad. And remember, if you guys are new to our community, be sure to also check out our Discord. We have a fantastic community in there. A lot of people are actually, interested in Nix, wanting to learn Nix and all that kind of stuff. And it's a good place, it's a good place to catch up and learn from people and stuff like that. So yeah, I recommend it. Fake Bryn, thank you for the follow. So the builder environment, right? Basically, home is not a thing. Relative things that make it. I see cat. I press follow. Oh yes, this is a sweet boy. His name is Alphonse. Oh, I'm sorry. I patted him and he's musing at me. He wants to be sleeping. Thank you for the follow. I appreciate that. And that's like a good idea, right? To not try and have anything relative, because relative opinionations can then change how the process works. Path plays the same game as home. Basically, path has its own path. It doesn't use the path that you're currently building with. And so that even could separate, this from even some other build systems that might inherit it, that are a little, just more like scripts and stuff like that. Nix build cores and Nix store are Nix configuration options. Okay. Print working directory and temps clearly show that Nix created a temporary build directory. So basically, if you are in a build environment and you do print working directory or temp, we should see that we are actually in a temporary build directory. Then builder, name, out, and system are variables set to the DRV's file contents, right? And so again, these are special environment variables that we use or can use, where we've got like the builder path, the name, right, the output path, and the system basically set as environment variables that we can use if we need to, which is what we did, right? We used that as echo foo out to this out path, which made a file in that location, right? Thank you for the follow. In terms of auto tools, out will be the prefix path, right? Yes, not the make dester, but the prefix. That's the essence of stateless packaging. You don't install the package in a global common path under /. You install it in a local isolated path under your Nix store. And so that's what we're doing, right? Is we're saying like, okay, out is the prefix path to where all of our binaries or all of our output, anything we're going to essentially build, that's where it's going to go. And look where it is. It's in the Nix store, right? It's not going to our user bin or anything like that, right? It's going to a more local place that we can then reference, right? So we've kind of already gone over this, and they're talking about this now too, like what is the DRV contents, right? The args attribute and how it changed, right? And I've already talked about this, how the builder got added as an args because we provided it as an args in the attribute set for the actual derivation, right? So again, args is right here, and if we look in our actual derivation, we can see that args gets translated into a configuration option with an array, right, of args. Outside of that, it's pretty usual. We could see here that the bash builder is in the Nix store, right? And any files or directories that are needed get automatically copied to the store, which is why we use that direct path, right? So instead of having a path in quotes like we do in args, we just say direct path /builder. Nix knows how to say, oh, okay, this is an actual file you want me to import. I need to add that to the store so that it's referenceable, it's immutable, it can't change, right? So that's another thing to notice is like, even if I use files locally, Nix is going to take those files and add it to the store and make them immutable so they can't change, right? Cool. Okay. Given that the builder.sh is a plain file, no DRV is associated with it. The store path is computed based on the file name and the hash of the contents. The store paths are then covered in detail in a later pill. So yeah, basically, it's just going to create a file. It doesn't need a derivation because it's already, basically been built. It's just an artifact essentially. Wait, by listening to all of this, does Nix make things more user-friendly, or is adds brand new abstraction users should spend years to learn? Does Nix make things more user-friendly, or is adds new abstractions users should spend years to learn? I mean, yeah, I definitely think it makes things more user-friendly once you get around some of the learning curve. Or it adds new. Are you saying or it adds new abstractions users should? I mean, I don't know. Wait, so you said you have a question, but but then you kind of said, or you kind of said two questions there. So I guess I can address it like this. Yes, it definitely makes things more user friendly because it has a language and a configuration and like a domain specific language that it has to adhere to. Like that's yeah, like in a Docker world, it's just bash. You can copy and paste a bunch of different things and right? But in a Nix world, it allows you to have more like, again, stricter, parameters, I guess. Does it simplify or things are complicates? I think it actually does simplify, but I think it's heavily focused on understanding that you're solving this problem with a language. You're not trying to solve it. Like, there's a massive difference between imperative versus declarative. And Nix is declarative. That means that when you declare something, you're trying to give as much information about something as humanly possible, right? Docker files are imperative. I can literally give a shell script to a Docker file and just say run, right? But even with Nix, right, when we talk about building a derivation, there's three basic attributes we have to give it, right? Name, builder, and system, right? Those three parameters alone give us the ability to set up of like where it should exist, what names should it have, what input should it have, what out, you know what I mean? Like there's so much just in those three standardized parameters that we can do with that. And again, that's why like even with, 4 parameters, whatever, we get this huge, like, again, not massive, but like all of these like computationally generated paths, right? How would you do this if you didn't have it? Well, you'd have to do it manually. You know what I mean? You would have to figure out ways of computing these paths. And like, that's why I was saying earlier, like, it's really nice to be able to just essentially take a derivation and then just like turn it into a string, and then bam, you've got its path, right? Its output path, right? That's super nice. That makes it really easy to do things like this when we want to just use bash, right? But we want to make sure we use the proper derivation path, right? And so that's where, we can just say, all right, well, we'll use bash and string interpolate it into bin bash with it, so that when the builder runs, it'll interpolate this into the actual storage or store path, and then we'll get bin bash, added to it. Yeah, like that, like in my opinion, that actually simplifies a lot of that, right? But it complicates it in the sense that you kind of have to understand, and there's a reason why we're going through these pills, all right, so let's do this. Let's start off by writing a simple program called Simple C. All right, so I'm gonna quit out of this really quickly, and we're going to touch simple.c, right? And we're gonna say void main good old-fashioned puts simple, right? Bam. Simple C program, right? And it's simple builder.sh, right? So we'll create a new file. We're going to call this simple builder.sh, right? And in here, we're going to say export path equals core utils bin, right? And recognize this, chat. Recognize this. Core utils is an environment variable. What does that mean, chat? What does that mean? What is GCC? How is GCC like, what are these environment variables, right? These are the environment variables that we are going to be adding as derivations in our dependencies that it's going to add, right, in our actual build. So I am writing a bash script, sure, right? But in this bash script, I'm saying I expect to have a variable called core utils that has the path of a derivation with the bin for core utils in it. Same thing with GCC, right? And so that enables me to be able to run GCC in my actual build, right? And make my directory out, right? The path of which I'm going to build the thing to. Instead of making it a file, it's an actual path this time. And then we create a binary called simple from the source, right? All right, so we've got that, right? And then we're going to go ahead and load this up and build it with Nix. All right, so we're going to start from the beginning. We're going to open up our REPL, right? We just have a brand new Nix REPL, and we're going to load Nix packages. Remember, when we load Nix packages, we literally load all of the environment or all of the variables inside of, the 80,000 package repository that Nix packages maintains. And it doesn't mean that I'm loading all 80,000 variables right this second. It just means I'm loading the first set, of references. It's a tree. So I'm gonna hit L, bam, I've got 15,490 variables. Cool. Okay. So some of these are, again, binary. Some of these are have other trees of attributes, but we've got all of our packages now is basically the idea. So let's build our application simple. So we're gonna say simple equals derivation, right? We're gonna create an attribute set. Name, right? Simple. Builder equals bash, right? Because we need bash, bin bash, right? Args equals, and we're going to import the simple builder.sh, right? Because it's just a simple builder. GCC equals GCC, right? Core utils equals core utils, right? What am I doing? I'm declaring variables or attributes that will then be passed down to the builder.sh, right? So I'm saying GCC equals GCC. That will be then an environment variable in my simple builder, right? Source equals simple C, right? Because remember, anything that we need, it's going to essentially link or add and then link. Add to the store and then link. Built-ins.current system. Okay. So before I do this, let's look at this derivation. So I'm going to build my first actual C-based application with Nix. All right. So this is probably the closest example to Docker as we could probably have, all right? So first thing in the Nix world, we're going to declare a new derivation and a variable for it, right? So we're going to say simple as our variable, derivation, and then the set of attributes for that derivation. So what is in this set? Well, we've got a name, simple, we've got a builder, bin bash. Why do we have bash like this? Because we're loading it from Nix packages, right? We added 15,490 variables. One of them is bash. And when we interpolate bash, it's going to give us the actual Nix store path of where bin bash is, right? That's just how it is like it is here, right? We then say args, right? And then args is going to import the simple builder. Oh, I didn't spell builder right. B-U-L... DER builder, there we go, builder, and this will then be added to the store, right? Now I can do the inherit, but just give me a second, Cran. Let me just finish what I'm doing before we change stuff. The file, right, simple builder, will be imported to the store and then accessible just like it was here, right? So again, we should have an argument that references the builder in the store, not the one actually, here. We then say GCC equals GCC and core utils equals core utils. Another way, if you wanted to save syntax, essentially, is what Cran is suggesting, which we can do, is we can use the inherit keyword, I guess. And that keyword enables us to basically say inherit GCC and then inherit core utils. And that will, instead of saying like GCC equals this and core utils equals this, it will basically do that for us. Now, I don't know if this will work like this. I would imagine it does. I know it works like this in the language itself, but I wasn't sure if it could work like this in the actual attribute itself. But yeah, sounds like it can. So source will then take our simple C. Yeah, I don't know either. That's why I didn't want to do it. Source equals / simple C, right? Just like our args, it's actually going to take our source code and then add that to the store as well, right? Now remember, just like our simple builder, it's a file. It's not like actually got its own derivation or anything like that. So these will just be added as dependencies in the store with their own change set files and stuff. And then the last one is system, right? So we're going to try the inherit way. If the inherit way doesn't work, we'll fix it. But that's essentially all of the attributes we're giving this. This would be comparable to, again, a Docker file, right? Where a Docker file has like from, has all these other things. What's the difference? Well, for starters, we didn't have to declare an operating system. There was no need for an operating system whatsoever. We really are just focusing on the software, its dependencies, and what we need. All right. So we're going to hit enter. And it looks like I might have missed something. There we go. There we go. Okay, cool. So I've got it. And if I do simple, what do we have? We have a derivation in our Nix store. So let's look at this derivation really quickly. Nix show derivation. And wow, look at this. Okay, so we have quite a few new items in our simple derivation. But let's take a look. So we've got our output path, right? So I'm just going to do ls-al really quickly, and we should see nothing. Great, that was expected. Input sources, look at this. Simple C, our actual source code, as well as our builder. Our derivation, we have multiple input derivations now. Bash, core utils, and our GCC wrapper, right? So look at that. It's added multiple dependencies for us because we simply interpolated their paths in our derivation, right? System x86-64, builder as well, a new builder path, but bin bash nonetheless. Arg, same thing, simple builder, right, with its store path. And then we've got our environment. And remember, our builder script is looking for core utils and GCC as environment variables. And what did I tell you those were going to be? I told you that those were going to be paths to the actual built derivation output for those, right? And so what that means is that now when this runs, it knows exactly where core utils and GCC are. So let's go ahead and build it. So we're going to say B, simple. We're literally letting it build now. Boom. All right. And so now that it's built, we have a derivation that produced the following outputs. And if we go back to that ls, look at that. Simple is now a directory with the simple binary inside of it. And so if I do simple, right? Like this, simple, boom. We just built our first piece of software with Nix and breaking it down entirely on stream chat. So there you go. That is a much more realistic scenario of building software with Nix, where we took a C application, we wrote a very simple, very simple script, or very simple, not script, but very simple print, essentially. We then made a builder for that, right, with the expected environment variables for the dependencies we needed. Again, GCC, core utils, whatever we needed to build our actual software with, those were also built with Nix, right? So we're reusing Nix derivations to use and build other Nix derivations, right? And then when we built that, we leaned on other environment variables for its out directory to be able to render where that output would actually go, all that kind of stuff, right? And then once we got that output, we were able to say, hey, well, let's try and actually see if it works. And so sure enough, if we reference that output path with the binary, bam, there it is, simple. Now, if we wanted to, I want to show you guys this really quickly. Look at this. If I do simple/simple, this gives me the exact path that I would need to run it, right? And that's what I mean by now we have reusability with a brand new package. Just like bash, when it gets string interpolated and we get bin bash, right? We could do the same thing now with simple because it's been built, right? And its path exists in our store. That should hopefully give you guys a very larger perspective on, how all of this works and why it's so nice to be able to reuse this. Like, look at this. We literally within 1, 2, 3 lines of code, we described what we were going to build with Nix in a derivation. We built that derivation, and then we reused that software in a string to do something else, right? So say if I needed to go do something else now, I could use this binary and say like, okay, cool, I'm good to go. I've got this built and it worked. Yeah, it's powerful, man. It really is powerful. It's something that I think, again, once you start I think reusability and reusing it more and more and more is going to be a big importance. If you don't use Nix a lot, then having like 1 or 2 packages you use every now and then, I don't think is going to be a massive value, right? But if you are like building software that depends on other software that's used by Nix, and then like, your environment is using Nix too, you slowly start saying like, okay, well, I can just add this, or I can just do this, and I can do that. I can lean on Nix more and more and more and stuff like that. But this is a good example of essentially at the lowest level what it looks like to build a piece of software with Nix, what that cycle looks like, again, of okay, we're going to declare our configuration or our derivation essentially with the language. That's going to render us a DRV file in our store, which we're then going to build, right? And then we get that output available to us that we can then now reuse in a different package or a different piece of software that we need to build. Del Void, what's up, man? How's it going? Of course, you normally wouldn't use yeah, exactly. Yeah, but this is at least a good introduction. These low-level this low-level derivation is a good way of getting started with it, right? All right, give me 1 second, guys. I need to go check my Slack really quickly because I think I actually need to hop into a meeting. So hold on 1 second. God, you guys didn't hear that. I almost like tripped over my desk. Ow, that hurt. Oh, that really did hurt. I'm headed for dinner. Catch you next time. All right, Cran, have a good one, buddy. Yeah, no, I actually need to be rolling as well. I did just check my Slack, and I need to get on a call with a fellow coworker, so I am going to go ahead and stop it here. Before I do that, though, I do kind of want to just quickly show over the rest of what is in this pill that we really aren't going to be doing, although it's not really that big of a deal. The explanation here is just really what I just explained to you guys entirely, how we took the application, we created a builder for it, we then wrapped the application, the source code, and the builder into the derivation attribute set, right? Generated that build and then got our output in the store. So again, the language works with the store, right? It's very important to realize that anything the language builds for you is going to be in the store. Anytime you need another piece of software that already exists, that's going to be in the store, right? And anything you need to build source code wise and stuff like that also needs to be added to the store, and stuff like that. The other thing that they do kind of show you here is enough with the Nix REPL. And this is what an actual like simple.nix file looks like. And I can actually show you this really quickly as well, just like super, super fast. We're just going to say simple.nix, right? And the idea here is now we're actually creating a real Nix file, right? We're not using a REPL, but we're actually creating a real Nix file that, would describe this build, right? And so we say with import Nix packages, just like we did in the REPL, right? This makes it available to us essentially everywhere. And then we say we need a derivation, right? And we say, okay, we want its name to be simple, the builder to be build or bin bash, args to be simple builder, right? There's the inherit that Cran was talking about before, source as well as system, right? So it's the exact same thing that we did in the REPL, except for now it's in like an actual file, right? And so if I save that and then I just do Nix build simple, or here, I'll do it with old school build, Nix build simple Nix, right? Bam, there we go. And so if I do this, ls-alh, right, there's simple. And so if I do this, oops. And you'll notice, you notice that it actually auto-completes for me. Do you know why that is? Pay attention to this really quickly. This will be the last thing I say before I go, actually. I wrote the configuration in the REPL, and then I took it from the REPL and put it in a file. However, I got the exact same SHA build down to the binary. Do you know why, chat? REPL magic? No, not really. kind of, but it's because nothing changed, right? Nix is trying to guarantee that everything will stay the same, and that no matter where you run its builds, as long as you give it the same parameters and stuff like that, it should be reproducible. Exactly. And so even though it's a variable in the language, right, I was able to essentially redeclare that variable in a file and rerun that and get the exact same build result, right? And so that's why it's the exact same path until I actually change something. So for example, if I was to go like this, right, and then build it again, then it would be in a completely new location. So that's another thing to note is again, Nix tries to really be as reproducible as possible, and make sure that it's giving you good parameters so that you can have that high reproducibility, right? And so whether or not you put this in a file and run it, or you put it in a REPL and run it, it should produce the same result every time until GCC changed, or core utils changed, or source changed, right? Or your system changed, right? Something here has to change for it to actually produce a new build, right? And there we go, chat. That is basically our first steps into working with actual real derivations. We first started the stream with our first derivation. Again, just understanding the parameters, the tooling, how it works, like how it creates files for us in the store, how it adds files for us in the store, how those files, then get properly linked to the paths that they need, right? And we've really kind of exemplified that by doing like NixShow, right? I think NixShow was a really good example of like, NixShow derivation, right? Where like we created something in the REPL and then we got this in our actual store, right? We generated this file with all of these, generated paths and things like that to all the software we needed. So I think that's really important to note about this first one. Our first derivation was just looking at that and understanding what all of that was. And then we said, okay, now that we kind of understand how this gets generated and how we, again, as it says at the end here, we instantiate or evaluate versus realize and build, let's create like a real working derivation. And so, we said, all right, let's look at the builder. And we said like, okay, let's create a simple script that echoes foo as a file in our actual store, right? And so when we go to build that, it'll run bash from a previous derivation in our store too. And then we should get the output of a file that says foo in it, right? And we saw that. We basically cat that file and we saw that it in fact had foo in it. Oh yeah, I am. Huh. Oh yeah, that's weird. What the heck? Yeah. I am, but I don't really know. I mean, I'm basically just going over everything I just said, but I have no idea why that just froze. Yeah. Well, I might just have to call it there anyways. Yeah, I have no idea why that froze. And I don't really want to switch it because like I don't want to mess with I don't want to accidentally show a different screen right now. So yeah, I think I'm just gonna call it there, chat. Thank you for hanging out with me today. I do appreciate it. I hope you do or have been enjoying the Nix series, by the way. Again, if you are new to our community, be sure to check out that little blurb right there. Basically, we are a co-hosted stream by myself, BG, as well as my good friend Atoda. Throughout the week, Monday, Wednesdays, and Fridays, you can hang out with me while I basically show you guys all of these things that I'm interested in or things that I'm working out through my day-to-day. Or, other tools, projects we're working on. Quirk is still a very big part of our lives, even though right now we're kind of focused on some other things. So yeah, we work on all different kinds of stuff during the week. And then on the weekends, Atoda is actually brand new to programming. He is just getting his feet wet with all of these things, whether it be front end, back end, and everything in between. And so yeah, if you guys are interested in a different perspective from that, yeah, feel free to check out Atoda streams on the weekends. But yeah, this is basically what we do. We also do IRL streams from time to time, gaming, stuff like that. So thank you again so much for being here today. I really appreciate it. We do also have our YouTube. Again, this is something we're starting to work on more. I've got a few videos up there now, which kind of do show some of the interest and things that I have already, automation, Nix, things like that. And the second link is also for our archives. That's where we upload all of our VODs and things like that. So if you ever want to catch, whether it be this Nix Pills series or something else, you can definitely do that through the YouTubes. Be sure to also join our Discord. If you ever have questions, if you ever need help, anything like that, the Discord is really the greatest place to go. We have a great community that's always there to help as well. So if you ever have questions about Nix, DevOps, career paths, whatever, it's a pretty great place. So we highly recommend you join that too. And the last thing is social media. Again, I am, I try and be on Twitter every now and then and be a part of stuff. But if you'd like to follow us on Twitter, feel free to. Thank you guys. Seriously, thank you so much for the support, the raids, everything today. Thank you. I actually think Purple Elf is live already again. So why don't we just go raid Purple Elf? They were kind enough to raid us, so let's just raid them again. So let's go say hi to Purple Elf, guys. They raided us literally earlier today. And so let's just give the love back. But thank you guys again so much for hanging out with me today. I hope you guys are enjoying the Nix Pills series as much as I am. Like I said, a lot of this is going towards YouTube videos and content like that I'm trying to create for you guys. So I also appreciate your patience because, yeah, there's a lot to learn here. And as I've said kind of within the stream a couple of times already, there's, it's also really hard to properly describe it in ways that it's just kind of clicks. And for me, I had to just do it until it clicked. But I want to try and figure out a way to describe it so it clicks easier for you. So that's my goal. But thank you guys again so much. Be sure to join the Discord, check out YouTube, all that good stuff. I hope to see you. I don't know if Atoda is going to be streaming tomorrow or Sunday, but he will be doing a stream this week as well. So I hope to see you guys for that. If not, I'll see you guys next week. Enjoy yourselves. Enjoy Purple Rain's wonderful stream. Have a good one, guys.